Welcome to this lecture. In this lecture, we are going to see about structured fault model. With example, we are going to see about the concept of structured fault model. Before that, hope everyone know the concept of structured 0 and structured 1 concept. Structured 0 means any one of the signal line is affected by structured 0. That is always connected to ground line, which means that line is always generates logic 0 when that line is affected by structured 0. When the signal line is affected by stuck at 1, which means that line is always connected to VDD, which produce only logic 0. This is the concept of stuck at 0 and stuck at 1. Consider this is the one given example circuit. In this circuit has 3 input line x1, x2, x3, 1 output line y. So from this one, we are going to calculate total number of fault sites and total number of single faults of given circuit. So from this circuit, consider here named as A input line, then B, D. Similar way, we can representing the input lines label. From this one, we are going to calculate the number of fault sites. That is, A is the considered one fault sites. B is another fault size 2, 3, E4, F5, 6, 7, 8, 9. Totally, this circuit has number 9 fault sites. From this fault sites, we are going to find total number of single faults for given circuit. Now multiply with 2 into 9. 2 is the considered as a stuck at fault model, that is either 0 stuck at 0 and stuck at 1. So 2 into 9, 9 means which means number of fault sites. So total number of sites is multiply with 2, which 2 means stuck at 0 or stuck at 1. Totally this circuit has 18 single faults. From this one, we are going to discuss the concept of stuck at 0 and stuck at 1 with example. So this table shows fault-free response and faulty response of each line is affected by stuck at 0 and stuck at 1. That is, the first row represent the input combination of this circuit. The second row represents the fault-free response of the circuit. The another rows are represents the each line is, for example, here A. So first third row is represents the A line is affected by stuck at 0. This is the output response of this circuit. Suppose A line is affected by stuck at 1. This is the output response of the circuit. So similar way, we represents the truth table of faulty response and fault-free response. Consider, first we consider this y is the fault free response value. For example, here we are applying 1 1 1. At the time, what is the ungate symbol output value of 1 1 1? What is the inverter output when we are applying 1 0? When we are applying the combination of 0 1 for this ungate, what is the output response? 0. When we are applying the input combination 1 0 for this OR gate, what is the response? 1. This is the output value for this input combination when we are applying this input combination. Suppose this line is, that means, for example, we take this line is affected by stuck at 0. This line is affected by stuck at 0. At the time, we are going to apply all the combination of inputs through this concept. We are going to find test vector. We are going to find test vector because we are not able to find when this line is affected by stuck at 0. Through this all the combination of input combinations, we are not able to find this kind of false presence. So when we compare both a fault response and fault free response, through this response only we are going to find the test vector. what kind of test vector, what kind of input combination when we are playing this circuit, at the time only we are able to find this kind of faults presence in this circuit. For example, we take stuck at 0 affected by this line. At the time we are applying input combination 0, 0, 0. What is the response of this gate for when applying 0, 0, 0. Similar way, this 0 goes to inverter. So at the time what is the output here? 1. When we are applying 1, 0, what is the response at the time? This gate symbol is AND gate. What is the response when we are applying 1 0 0? So when we are applying 0 0 input combination for this OR gate, what is the response? What is the response? 0. This is the output value when we apply input combination like this. So now you compare both value. That is fault free response is 0. The faulty response equal to 0 when A line is affected by stuck at 0. Similar way we apply 0 0 1 combination. At the time fault free response is 1. Faulty response also 1. Then now we compare both outputs, both are same. Now we assume this is that line is not affected by any kind of fault. Then we move to next combination of input 0 1 0. At the time what is the faulty response, fault free response? 0. Then faulty response also 0. So from this combination we are not able to find this fault presence in this circuit. Next we apply 0 1 1 combination. At the time also fault free response 0, faulty response also 0. Both are same. We are not able to identify this false. Then when apply 1 0 0, at the time fault free response 0, faulty response also 0. Both are same. We are not able to identify fault. When we are applying 1 0 1 combination, at the time fault free response 1, faulty response also 1. We are not able to find when we are applying 1 0 1 combination this kind of fault. So next we move to the next combination 1 1 0. At that time when we are moved to the next combination 1 1 0, that is 1 1 0. But this line is affected by stuck at 0. So when we are applying the one combination here, this line is affected by stuck at 0. Always this line is generates only logic 0, whatever inputs we are giving here. But this line is affected by stuck at 0. At the time it generates only logic 0. So based on this concept only it generates the output, propagate the output. That is here now value is considered as 0 1. So 0 1 means at the time what is the output of this AND gate? 0. But our expected result is 1 because when our applying value equal to 1 1, but this 1 is changed like this. According to this value input combination it generates output like this. So this one goes to this inverter. This inverter output value consider changes, output is 0. So here also 0. When we are applying both inputs are 0 means the output of the AND gate is 0. So for AND gate inputs are 0 0 now. But what is the output here? 0. But our expected result, that is expected behavior 1, but we are getting value only 0. Now you compare both outputs, both are different. So automatically there is some false presence in this line. So this is the test vector to find the false presence in this circuit. This is the test vector to find the stuck at 0 fault. In similar way, next we are applying another combination also 1 1 1. When we are applying same this kind of input combination for this circuit, at the time our original response, that is fault free response, is 1, but our faulty response equal to 0. So both outputs are different. Automatically this is also comes under test vector to find stuck at 0 at A line. This is the overall concept of stuck at 0 and stuck at 1. Similar way, we are finding the test vector when this line is affected by stuck at 1. So here, what is the test vector when this A line is affected by stuck at 1 means the when we are applying input combination 0, 1, 0, 0, 1, 1. So at the time we are getting a different output response and compare with our original response. So this is the test vector for A line is affected by stuck at 0. This is the test vector when the A line is affected by stuck at 1. So similar way we can calculate the test vector for all the fault sites. So from this one we summarize the fault modeling abstracts physical defects. Stuck fault is the most popular model. It improves test quality and it enables reliable VLSI systems. Thank you.